Hi everyone. Thank you for joining us for the second part of the pre-last day of our conference 2025, and we are still here for you. My name is Oksana Belavus. I will be your moderator during this session, and I will monitor all your questions, and they will be announced after their presentation. Also say hi our tech moderator Alexei, who is in background but is responsible for our tech stack through the whole presentation. At this time, we are talking about open source agents for automation process. And we are very delighted to see Robin as our speaker. So it's great to have you here on ProQuality conference. Yeah, and dear audience, please feel free to ask any questions on the YouTube chat and we will address them for our speaker in the Q&A session part. Also, don't forget to subscribe to our YouTube channel. And our team always tries to emphasize the importance of your feedback. Please send the pages to the speaker and moderator and rate the event at the end as well. So, Robin, before we start, I have a question for you. Should we always review the results generated by AI agent, or can we trust it absolutely?
Wow, I think there are tough questions in the beginning. See, I would say we should always review the results. We should trust it, but with a pinch of salt. We should always have human at the center because we are talking about quality, not essay writing or drawing. So every output from the agent should definitely be reviewed by humans. And we will answer that question in detail in exactly 4 slides again.
Yeah, okay, so let's get started then. And I will pass floor to you.
Awesome. Thank you so much. First of all, thanks to everybody joining us, watching the presentation. As Oksana highlighted, please feel free to ask all the questions, even the tough ones. So let's get going. Today's topic at hand will be open source agents for in-sprint test automation. Okay. Um, I will quickly get going on the presentation. First, a brief intro. My name is Robin Gupta. I'm calling in from Bangalore, India. I'm the CEO and co-founder at TestZeus, and we build AI agents for test automation. I have 15 plus years of experience in product engineering applied AI. I have managed core products generating $10 million plus ARR. I'm a published author on the topic of software testing and automation and an open source contributor to projects like Selenium. So that's a brief about me. Today's agenda is very simple. We'll understand what is a sprint cycle, the cost of poor software quality, the new problem in town with AI agents, how to solve them using AI agents, technical deep dive, the future VC, and then Q&A. First and foremost, we see that there's a $1 trillion quality problem. But how so? When we looked at research, again, thanks to sources like Perplexity, Grok, and ChatGPT Deep Research, we found that the cost of poor quality in US alone is $2.4 trillion. And there are these three basics to it. One part is that we have found that developers spend quite a huge amount of chunk of their time in building out the tests and then running them. Second, we observed as part of the data that finding bugs in production is at least 6x more costly than finding it in pre production. And last but not the least, while everybody says we should go and automate the test cases, 64% of test automation projects fail to deliver value as expected. Now, some of these contribute to that $2.4 trillion problem, but then there are other problems as well. Those were the existing problems. We have a new problem in town, or maybe a new solution. So these are called the Make a Wish apps. If we quickly switch to my other screen being shared, we will see one of these examples in action. So we'll see the example in the shared screen, and we'll see the example about bold.new, wherein it's a Make a Wish app. So if I just scroll to the top, I have given a simple prompt. Create a landing page for ProQuality conference because we are attending the ProQuality conference. Now, what this application did was that it made a plan for creating that landing page, created all the artifacts and all the files and the code. So on the right hand side, we can see that in the online IDE, this AI agent, the system bold.new has written all the code for us. I did not write even one line of this code. And under a minute or so, we had the ProQuality conferences landing page ready. Isn't that magical? That you can just make a wish that, oh, we should have a landing page for a website or maybe a full blown SaaS application. And then these dev agents swarm together to create that artifact for you. Now, while that seems magical, if we look at the details, that is where the devils lie. For example, the dates are all wrong. We are presenting this on June 5th, but the dev agents hallucinated and mentioned the date as June 15th and 17th. Location is in San Francisco. We would love for all of us to be there, but here we are online, and so on and so forth, right? So that is the problem or the new problem at hand, that when we have these dev agents who can build out applications at the speed of light for us, they can also hallucinate at the speed of light. And that is why test automation, which was running slightly behind the agile sprint, is running even further behind the development cycle. If we switch back to the presentation, let's quickly look at the remaining topics at hand. So we saw that Make a Wish apps can help you fulfill your wish, but then all of those wishes can come at a cost. So the big question at hand today, how do we balance quality? Just let's pause over here for 10 seconds. Earlier, when I used to work with engineering projects or as a software engineer or tester, we had a 10-day agile sprint. So day one, start with the requirements, work in the sprint, daily stand-ups, so on and so forth. The last day, have a working output. In that case itself, given the breakneck speed of development, testing and automation used to fall a little behind development. And then automation would generally run one or two sprints behind the actual development cycle or delivery cycle in Agile. With these latest advancements in AI and dev agents, the big question is, how do we balance quality? One of the examples of the solution is Hercules, or the world's first open source testing agent, which we have built out. So, what it does is it takes natural English language tests as inputs and performs UI, API, accessibility, security, or even visual validations on behalf of the user. It is a no code, no maintenance solution and a fully autonomous execution agent. If we switch back to our other screen, we will see it in action. Okay, I will quickly go over to my IDE and we look at a very simple example of how we can do account creation on Salesforce. If you're not aware about Salesforce, do not worry. It is a CRM, and since it is a CRM, you can do account, contact, leads, opportunity management. Not only that, you can also customize it as per your taste and requirements. And then, since you've customized it, you can also test it out. But keeping all those complications aside, in very simple words, just read the test case at hand. It says, given I'm logged into a certain environment and I navigate to accounts from the app launcher and I click on the new button and I enter the account name as test account and append the current time to it. And I enter the billing street as Greece and I click on the save button, then the toast message for successful account creation should be displayed. Now, there are three magical things happening on the screen. One thing is that the test case itself is in natural English language. There is no code, there is no locator. For people who would know about the Gherkin syntax, would say, there could be a Cucumber implementation in the backend. Interestingly, there is no hard coded Cucumber implementation or a DSL for this test case. This test case will act as a prompt and will be passed to the multi agentic system, which we will see in a minute, and will be run autonomously by it. So, in simple words, the first magic trick is all natural English language and no code, no locators, no script. Now, since we did not write any code, Even if any of these UI elements change, we don't have to maintain it. And the third magical thing is that while we can provide the exact details of clicking on a certain element, we can also ask this agent to just go on to Salesforce and create an account, or go on to an e-commerce website, search for yellow sneakers, and then place them in the cart. Since we are using a multi-agentic system, henceforth the agent deciphers that test case, creates a plan, and then executes it. But much talking, so let's get to some execution. So on my terminal, I've already installed TestView Hercules. When I run it, what the system will do is it will take this test case as the input prompt and it will start running the test case. So it has launched the browser and opened the Salesforce screen for us. We can pass the credentials through test data or from the response of an API. It will take those credentials and log in just like a human into the application at hand, which in this case is Salesforce. Very quickly, it will browse through the application as per the instructions. For here, we see that it has gone on to the accounts list screen. It has figured out on the UI where is the new button, clicked on it, and thereby opened the new account modal. Now over here, we had asked the agent that append the current date to it, to the account name. So it has done that, and then it will fill all the other relevant fields on the UI. So that is the magic of autonomous test execution. Because we can provide test cases in natural English language, as we can see, the agent can help us achieve in sprint test automation. We'll talk about that more in a minute. But what we see on the screen is that the agent has created a new account and is navigating through the UI without us writing even a single line of code. This is not just interesting, let's quickly see how it achieved that. And if we look at the output, we see that a test case has passed, but the real magic lies in the multi-agentic system. So let's quickly jump back to our presentation so that we can do a deep dive into the technical implementation of this agentic architecture. So while we are here, if we go to the next slide, we can see that this multi-agentic system is actually made out of multiple layers. What happens is that when we pass the test case as the input, that test case first goes to something called as the planner agent. The planner agent takes that test case as the input, breaks it down into an executable plan. In our case, when we asked it to create an account on Salesforce, those 7 8 lines of prompt or test input were further decomposed into 10 to 12 or maybe 14 lines or so of the test execution plan. That plan is then coordinated with multiple agents, such as a browser agent for browser instrumentation and control, or an API agent for making REST API calls to execute that plan. For example, in our case, we had asked it that it should go on to Salesforce and create an account for us. Now, since most of those steps were from the browser, so the planner agent created a plan out of it and then passed it to the browser agent. The browser agent opened the browser for us, took that plan, and then ran with it until it completed all the steps. Once it completed all the steps, it reported back to the planner agent, okay, I'm done with the test execution. You can go and report the results back to the user. In this same example, let's say if we had API steps, visual validation, accessibility, or security steps, then the corresponding agents and tools would be called to complete that part of the execution. Once each of them would have done their job, they would report back to the planner, and the planner will consolidate the result and push it back to the user. A brief insight into how the browser agent would work is that the browser agent has the access to tools such as the Chrome browser and Playwright. Why I'm saying tools is very important here. Because, for example, Playwright is a tool for the browser agent to automate the browser. What would happen is that the browser agent will take an input such as click on the save button. So it will first sense the environment that, okay, do I see a save button on the UI or a new button or a certain field on the UI? So it will first locate it on its own. Once it locates it, if the action was click on the save button or click on the new button, using Playwright, it will emulate that click. Once it will click it, it will ensure that it is in the right state of the UI and then mark that step as completed. So that is how this sensing and acting loop will keep on happening with the browser agent and its environment. This is similar to how a user would also interact with an environment such as the browser or an API. Looking at the other parts of the technical architecture, so we looked at the agents. So it's a multi-agentic system. We had the planner agent, we had the browser agent, API agent, and the others with their corresponding tools and interaction mechanisms. We can also provide test data. So during the execution, the plan is created and the test data is injected at the time of the test execution. What also happens is that once all of this is run, the agents collate that result and push it back to the user in consumable format. So that is how this multi-agentic system takes natural English language as input, runs it, and gives the result back in simple words. I would urge our audience to explore the GitHub repository for test use Hercules and then go into these parts on their own. That brings us to the next slide and to the title of this presentation. We promised how to achieve in-sprint test automation using open source AI agents. Very interestingly, in the earlier world, we had humans and tools perform these steps of the test automation in a certain cycle or in a certain loop. For example, we had the analysis. Based on the analysis, the plan was created. Once the plan was created in the 2 week sprint, developers, designers, engineers, and product folks would do the design, build, test loop, and then do the final deployment. What would generally happen is that given the breakneck speed of development, test automation would fall one cycle behind the agile delivery cycle due to various factors, such as if there is an impending delivery date. If I have to test out an application, I would first test it manually, certify it for the release, and then in the next cycle, I would add it to my backlog for test automation, write the Selenium code or the Playwright code, and then complete the test automation for that and close that ticket or mark it as done. So in this case, in the current cycle, test automation would always run one cycle behind as compared to the delivery cycle. But as we saw, using systems like bold.new or GitHub Copilot or a cursor, now development is moving further ahead of this test automation. And when we felt that test automation is falling multiple cycles behind the development, we came up with Tesu's Hercules so that open source agents can help the test automation to happen within the sprint itself. And for folks who would recognize this pattern as test driven development, our aim is that can folks write acceptance criteria in the Jira ticket? Now, that same acceptance criteria can be passed to the dev agent for development and the test agent, such as Test Use Hercules, for testing. Both of these work in parallel to achieve that goal. So, that is the future that we see. Finally, humans plus agents, such as Bolt for building, Hercules for testing, and Figure for design. The idea is can we run these mini sprint cycles at much higher speed, wherein humans and agents help us achieve not only new levels of autonomy, but also higher effectiveness and efficiency, and thereby achieve in sprint test automation. That also brings me to the last section, Q&A. Please feel free to shoot questions and date the event, passing the ball back to Oksana.
Mhm. So thank you so much for the presentation. That was a really interesting approach of using this AI agent with practical approach here. So, dear audience, if you enjoyed the talk, please scan QR code to rate our event and give Robin a badge. And now we're starting Q&A session. If you haven't sent your questions yet, that's a sign to do that right now. So let's see what questions we have. And the first question from YouTube. Is it possible to automate native mobile application this way?
Okay, the answer is yes. If I share my screen back, I can show you a secret part of that GitHub repo. So on our GitHub repo, while we have all these features available and the documentation available, if we go and look at a certain pull request, which we haven't got the time to merge into main, we can see that we have also built out the mobile testing support. So what we did is we actually built out mobile testing support, but we never got the time to fine tune it and test it out and merge to main. But in this case, to the question, just like we have the browser agent instrument, the browser, and Chrome and Playwright were the tools, we looked at Appium as the tool for mobile automation. And using the same fundamentals, we can automate the mobile as well with this experimental PR over here. So try it out. It did work out for us in sample test cases. To the question, can we automate mobile? Yes. Give it a shot, try it out, and if you guys are happy, we'll merge it back or raise a PR. It's all open source.
You definitely need to try it, right?
Yeah.
Okay. So the next question. Can you explain how open source AI agents differ from traditional test automation tools? Hmm.
Okay. Very tough question. I think, but the answer is really simple. See, the answer lies in that question itself, somewhere hidden, because it is asking how are these autonomous agents different from tools. If we go by the definition, tools are things which you have to use. You should have the plan, and then you use that hammer to put a nail in the wall. But agents come from the word of agency, so they have autonomy. When we give the test case to the agent first creates a plan of execution, and then using tools such as the browser or the mobile, completes that whole plan on its own. So that is how they are different in this very basic fundamental point that in tools, people have to use the tools, break their head, learn how to use the tool and all that. But in the case of an agent, you provide the agent with a goal, and the idea is that the agent should achieve that goal on its own using tools and autonomy.
So that's a great point. Thank you for detailed answer. And the next question. Can AI agents prioritize test execution in CI/CD based on feature critically or user impact defined during sprint planning?
Okay, there is a yes and a no answer to it. Can AI agents prioritize test execution? Yes. In our limited experiments, what we have found is that if we provide the right context to these agents, they can prioritize just like how humans. So if let's say somebody were to ask me, Robin, prioritize these 10 test cases for execution, I would ask, what is the business use case? What have been the past failures? What is the customer looking for? And what time of execution do you have at hand? And then I'll make that priority list. Interestingly, if we can provide similar context to AI agents, to some extent and degree, even they can prioritize the test execution. And to Oksana's point earlier, once they're prioritized, humans should review that and then go about executing them.
Oh, so yeah. Okay, and the next question, how do you ensure that the AI agents remain up to date and compatible with evolving development practices?
Okay, I think the third time we are putting humans on the podium, but how we ensure that AI agents remain up to date is humans should do it. So when we look at an AI agent such as Tesu, Hercules, or any other, the whole idea is that since these are built on top of code and could have multiple dependencies, Therefore, the onus and responsibility lies on us humans or the folks building this out to ensure that they are up to date and are compatible with evolving development practices. For example, if there is a dependency which could have some vulnerability in it, so that responsibility is on us to scan the repo for vulnerabilities, maybe using Snake or open source tools, and ensure that the agents are up to date and are compatible with the modern world.
Okay, let's keep that in mind. And the next question, what advice would you give to teams looking to adopt open source AI agents for their test automation efforts?
Okay, I think that's a very good question and asked very frequently whenever we do this kind of a demo. The answer is actually very simple, that we should look at the adoption from three angles. We should look at the scope, the timelines, and the budget. So what that would mean is that first we should define the scope, that okay, if we were to adopt this open source AI agent, we want to test out these few things across these parameters. Maybe I need to improve my test automation coverage. Maybe I need to improve the velocity of test automation, so on and so forth. So define the scope, that is one. Now, based on the scope, we should have resources. It would not make any sense to work on the adoption if we have only one member in the team who is already overloaded with 50 things. So we should look at the scope and the resources at hand. And then last but not the least, A and B should lead to C, which is the timeline. So based on the scope and resources, we should define the timeline for the adoption so that we can actually achieve the goal which we had set out as part of the scope. So that is how people can go about adopting AI agents as part of their development cycles.
Yeah, we should also take into consideration the scope and the resources, right? I agree.
Yes.
So, and the next question, what is your opinion on having humans in the loop to make agents better?
Okay, I think we started with this tough question, and again we are here. But what I would highlight is that when we say humans in the loop to make agents better, for example, when we ran the test case or when we ran bold.new to create that landing page, the responsibility is on the humans to do the actual versus expected comparison. What that would mean is that when we are writing that prompt, from that prompt to the execution result, while the agent will do the whole delivery or that execution for us, the responsibility at the end is on us to see that okay, we gave prompt A, the agent did 50 things in the middle, and the output for that prompt A is this expected result, and we do that matching. Now, in our case, we do that through screenshots and videos and other artifacts, or even a playwright trace being generated after the execution. So, a human or the person responsible for running this magical technology at the end should review all those artifacts and say that, okay, the agent did not hallucinate. It actually achieved the goal or of the prompt that we had given.
We always should think when we compose and create our prompt, right? The
Yes.
basic thing. Yeah. Okay. And the next question. How can we make sure that we have enough coverage generated by AI tests? Can AI provide that statistic?
Okay, I think that is a very interesting question, which me and my co-founder ponder upon on weekends and late nights. I think let me break that question in two parts as it is asked. One, can AI provide that statistic? Statistic, yes. AI can always provide numbers because it is also made up of numbers. So it can always tell you that we have 70% coverage, 80% coverage, so on and so forth. But in my own experience as a tester, when I started my career, I've realized that coverage is a very elusive metric. Just when you feel you have the right coverage, it will move out of your hands like you are holding sand. Because coverage is not a static number. At least from my own experience, what I have found is that coverage is based on not just the development efforts, but real time statistics and inputs as well, such as support tickets or Play Store reviews. So, to the question, how can we make sure that we have enough coverage? I think that responsibility would lie on humans and the business context of that application. And rather than focusing on a number, we should focus on the business context and the real value, like a CSAT score or the increment in revenue. Those things would be much more helpful for the business.
Okay, thank you for your interesting answer. Yeah, and the last question for today. What are the main benefits of this AI agent and how does it differ from other existing ones?
Okay, so two parts. So I'll answer them in two parts. The main benefits one, it just looks magical. So I'll run a test case and I'll look at it and I'll think about my old days of automating stuff by hand. But okay, I'm kidding. That is not the main advantage. The main benefit is that using such agents, now you can shorten the gap between development, delivery, testing, and automation. And you can also start inculcating these good practices such as test driven development, where you first write the test case and then do development or automation to fulfill that test case. So that is just some of the benefits. How is it different? I am biased because we built it out. But what we believe is that in our study, we found multiple AI agents who could do test automation. But Hercules is the only full stack end to end test automation agent. Because it's a multi agentic system, therefore, it can not only do UI, it can do API, accessibility, security, and even visual validations. Because it is using these tools to complete that testing. There are existing ones, but they are very browser focused and not built out for testing. So that is the short answer on the second part.
Yeah, thank you so much. And I suppose that was the final question for today. And thank you so much for sharing your experience today with us. And dear listeners, thank you for supporting this event. And don't forget to send the page for our speaker and rate event as well. The presentation deck will be uploaded tomorrow on our talk page, and video recording will be available on the YouTube channel within 1 month after the conference. And yesterday we defined that the fact is that 18% of our viewers are not yet subscribed on our channel. So let's do it right now. And it's important for us and for our growth and future events. So we have a lot of plans for future events and don't miss it. So it's the final topic for today, as I already mentioned, and we are looking forward to seeing you all tomorrow morning for sharing insights on using Git to enhance commit quality and testability in software projects. Stay tuned, join ProQuality community in our social network. Have a great day. Thank you, Robin.
Thank you so
Bye bye.
much. Bye bye.